everybody. My name is Jared Evans. I'm the corporate marketing manager for ALS in North America. And I want to thank you all for joining us today on our webinar Wednesday. We have a special presenter here today. Nicole Bryson is the technical sales manager for the ALS Environmental Laboratory in Southern California. After completing her undergraduate degree in chemistry at St. Lawrence University, she worked as an analytical chemist in the pharmaceutical industry. After finding that the life of an analytical chemist didn't exactly suit her extrovert nature, Nicole proceeded to complete her MBA in marketing from Pace University in New York in 2000. She has been working in the environmental industry for the better part of the last 15 years. And she has specialized in air and vapor sampling and analytical methodologies for more than 10 years. Nicole works closely with the ALS Air Quality Laboratory in Simi Valley, California. They have do a wide range of air, vapor, and gas analytical services, and they have been doing so for more than 30 years. So a lot of technical expertise and capabilities at the Air Quality Laboratory that we have in Southern California. Right now, Nicole resides in Irvine, California with her geologist husband and their beach-loving retriever. So with that, I'll turn it over to Nicole, and I'll let you guys know that if you have any questions, just enter the question in the chat box or the question box, or raise your hand, and I will monitor that and let Nicole know when you guys have questions. So Nicole, thank you, and thank you everybody for attending, and I'll turn it over to you.
Good morning. Thank you for the introduction, Jared, and thank you everyone for listening in. Today we are going to talk a little bit about landfill gas and biogas, characterization, sample collection, shipping. We'll start off with a brief review of what are the analyses that our laboratory most frequently gets asked for from clients who are characterizing landfill gas, biogas, digester gas. What are the methods that are requested and the parameters? Quick look at what are the applications, under what situations or practices do we find our clients are utilizing these methods? What are some of the new requirements and parameters that we have been getting inquiries for, and where might they be coming from? A big question that we get a lot is, how do we collect these samples? How do I collect them? And then how do I get them to the laboratory? So those are some of the things that we'll be talking about. As Jared indicated, we are taking questions, and we'll have a pause about halfway through. So without further ado, let's talk about some of these parameters and methods. In landfill gas and biogas, we most frequently see our clients asking for characterization of these parameters: methane, TGNMO or NMOC, fixed gases other than methane. Sulfur compounds are often of interest in digester gas, biogas, landfill gas. For customers that are interested in the BTU value, we also support that. VOCs and siloxanes. Now, there may be other methods that are available, but as an environmental laboratory, our specialty is in environmental methods that come from either the EPA compendium from source testing, which is where EPA 3C and 25C come from, or from the TO compendium, which was developed for ambient air. When I reviewed the methods in the EPA compendium, I really just found two methods that specifically cite landfill gas, and 25C is one of them. And that's what you may have requested for TGNMO. Similarly, the sulfur analysis is one of the few ASTM methods that I could find that specifically address landfill gas. So this matrix, landfill gas, biogas, digester gas, these are matrices that don't have a lot of methods that I could find that are specifically developed for that matrix. So you're going to have to use methods sort of from other practice areas that are either modified or adopted for landfill gas. The ASTM method for sulfur is unique in that it utilizes a detector that is specific for sulfur compounds. It uses a sulfur chemiluminescence detector, and that makes it much more sensitive for sulfur characterization than other instruments, say GC mass spec. And with that, we're able to characterize a list of up to 20 sulfur compounds. So under what situations do we get inquiries, and what applications and practice areas are people doing this kind of testing? Well, for routine monitoring, we get inquiries at landfills, but sometimes you may be required under compliance testing or for permitting to do some of these tests. The New Source Performance Standards and Emissions Guidelines for municipal solid waste landfills require landfill gas emissions controls. And this rule provides the owner and the operator of a landfill with a tiered system for determining if controls will be required. So what that means is that under Tier 1, an owner or operator of a landfill can calculate what the NMOC emission rate would be. And if it's less than 50 megagrams per year, then they submit a report and just recalculate it. Tier 2 testing is where you have to actually determine the concentrations. So we get inquiries from our clients to perform Tier 2 compliance testing. The thing that makes this different than the routine monitoring or routine testing we might see for some of these parameters is how the laboratory needs to run the method. In Tier 2 testing, EPA 3C, which can be used for fixed gases for methane, carbon monoxide, carbon dioxide, oxygen, nitrogen, hydrogen, per the method, it has to be done with a duplicate injection. And this is what's required under Tier 2 compliance testing. Similarly, the method for NMOC has to be run in triplicate. So if you are going to be doing Tier 2 compliance testing for your landfill, it would be important for you to communicate that to your laboratory prior to the analysis to ensure that they run it properly. Otherwise, for more routine applications, the laboratory would do a single injection for both of these methods. So if you're doing Tier 2 testing, you just want to make sure you can communicate that to the laboratory so that they can perform it in a way that will meet your requirements. We also see many inquiries for these range of parameters for our clients that are involved in gas to energy applications, which we have really seen increase in the last few years as facilities are looking for ways to capture the gas generated from their facility, whether it's a landfill or if they have a digester, and either using that gas for their own facilities needs to power their own turbines or their own vehicles, or if it's refined enough and clean enough to sell it back to the grid. The parameters that we typically see requested for these applications include fixed gases, sulfur compounds, and siloxanes. Siloxanes represent a specific challenge. Siloxanes refer to this functional group, which has a silicon, oxygen, and silicon functional unit. They can be branched compounds, they can be cyclical, like the compound on the left here, which is referred to as D5, decamethycyclopentasiloxane, or they can be linear, like the compound on the bottom right, which is L3. Also, it's octamethyl trisiloxane. These chemicals are of interest in gas to energy operations in that they can be generated from landfills or from digesters because they can negatively impact the performance of the turbines. Now, the challenge with characterizing these chemicals is that there are no promulgated methods for the sampling and analysis of siloxanes. Promulgated refers to official methods. So there are presently no methods for characterization of siloxanes from EPA or any state agencies. That's because method development by those agencies or entities is typically driven by risk, whether it's risk to human health or risk to the environment. Since siloxanes are not currently associated with risk to human health or the environment, there's no driver for an agency like the EPA to develop a method to characterize them. That means that in order to do that, laboratories have come up with their own methods. So there are many methods that are available commercially, but they have all been developed independently by laboratories. What that means is that there can be many variables in the methodologies, and it's been very difficult to compare results for siloxanes among different laboratories. There can be differences in the sampling media that are used by these different methods. We are aware that the different sampling media that are used are things such as tubes, Tedlar bags, Suma canisters, oil, and impinger solutions are currently used for the methods that we're aware of. The analytical instrumentation can vary depending on the laboratory. Most laboratories use a GC, a gas chromatograph, but the detector that is used can vary from a mass spec, an ICP, or an AED. The calibration standards vary. Some laboratories use liquid phase standards, some use vapor phase. The target analyte list can vary from 5 to 22 chemicals. The reporting limits vary greatly, and the way that laboratories calculate and then report the siloxanes also varies. So some laboratories report total siloxanes but don't speciate them. Some speciate them and then provide results in milligrams per cubic meter, milligrams silicon per cubic meter, ppmv, ppmv is silicon, or micrograms silicon per meter cubed of methane. So currently, when it comes to characterization of siloxanes, there are a lot of different approaches, and it can make it very challenging to compare results among laboratories. Our laboratory has developed a sampling and analytical approach for siloxanes in biogas and landfill gas. In our method development process, in our research and development, our chemists determined that a sorbent tube yielded good recoveries, better than what we saw from canisters. So our method utilizes a sorbent tube like the one pictured to collect the sample. To collect the sample, you would connect this tube to your system, whether it's landfill gas or a digester gas, with tubing. We provide a rotometer and a slipstream so that you can regulate the flow. You pass the gas through this tube, and you document the flow rate and the time so that you have a volume that you know is collected. Then you send the tube to the laboratory, and we do a solvent extraction to get the target analytes from the tube. And we analyze it by GC mass spec, similar to EPA TO15. This is what our report looks like. So you can see that we can speciate the siloxanes below. Our results are in micrograms per cubic meter, as well as micrograms silicon per cubic meter. And we also provide a number for total silicon in the report. So this is what we provide. And again, it can be challenging to compare it among laboratories. So if you get results from different labs, it's important to think about what instrument did they use, what standards, what collection method. As we indicated, there are no methods currently available for siloxanes, but we have been working with the ASTM, and it is anticipated that they will be publishing a method for siloxanes this year in 2018. And it will include our methodology for sampling analysis and QC criteria. Just take a brief pause here. Any questions at this point, Jared?
No, yet. No questions.
Okey-doke.
We'll just remind people that if you do have a question, you can click the little hand raise button or just enter your question on the chat box, and I'll get it from there.
Okay, great. Thanks. So we'll move on, and I want to talk a little bit about some of the new parameters that our laboratory has been asked for, and ask you in the audience what you may have been seeing. Some of the parameters that we're asked for are pretty common, the ones that we talked about: methane, fixed gases, VOCs. That's fine. But some of the as I discussed earlier, there are not a lot of sampling and analytical methods specifically for this method, for this matrix. So if it's digester gas or biogas or landfill gas, you may have to modify either an ambient method like a TO method or a NIOSH method or source methods, and those all have trade-offs. Some of the things that we have been asked for increasingly in the last year are some of the parameters on this slide. This is true specifically in California, due in part, I believe, to rules that we have seen from PG&E and SoCalGas with regard to entities who are interested in providing gas back to those entities. So we're being asked now to characterize landfill gas or digester gas for things like metals, arsenic, antimony, copper, lead, mercury, ammonia, chlorine and fluorine, biologicals like acid-producing bacteria, sulfate-reducing bacteria, iron-oxidizing bacteria, dust, organic silicon, density, moisture, N-nitroso-di-N-propylamine, Wabi index. Now, some of these parameters are being requested for human health risk as possible carcinogens. Some of them are requested as pipeline protective parameters to make sure that they're not present because they might negatively impact the pipeline. And the challenge with these parameters is that there are no clear sampling and analytical approaches for landfill gas or digester gas. In the case of metals, there are methods available. You could use like EPA method 29 from sort of the source practice area. EPA method 29 utilizes impingers, and that can be sort of a more onerous prospect to use impinger solutions and modifying that sampling approach for landfill gas or digester gas. There's also a NIOSH method, 7300, that uses a filter, which is pretty easy. It's pretty cost effective. The challenge with that is if your landfill gas or digester gas is very humid or very hot, it may not perform well with that filter. A filter wouldn't perform very well if it were exposed to that humidity. So the challenge is how, going forward, do we modify the existing sampling and analytical approaches to be able to capture this range of parameters? So, I would be curious to know, for you folks in the audience, what parameters might you be asked to characterize by your clients or your regulators? And how are you managing the sampling and analysis? And is this a challenge, or is it a piece of cake? Like, have you figured out that you can just modify a couple of these methods? There are some guidance documents out there from, for example, GTI, the Gas Technology Institute, which does give some pretty good direction on how some of these might be modified. But the way that this would then be practiced or applied with commercial laboratories is a little bit more challenging, since laboratories have to follow promulgated methods. So while there are some resources out there, I'm curious to see how this is going to develop as this application and interest in our industry proceeds. So after the webinar, if you have any thoughts on this, please shoot us an email or give us a call, because I'm definitely curious. So that said, we'll move on to sampling. How do you collect these things? No one-size-fits-all approach is available, because as we saw with that range of parameters, the thing here on the left is an impinger. You could use that for metals or for some of the chlorine and fluorine. The cassette there is what you might be able to use for the metals, but you can't, if you had to do metals or some of the semi-volatile, the NDPA, that cannot be collected. It has to have a solid sorbent. You could use a bag. So as we move forward and as we get more parameters that we're trying to assess in these matrices, the reality is in the field, you're going to probably have to use more than one sampling approach to get a broad range of parameters. Once you have the sample, how do you ship it? So landfill gas and biogas, digester gas, typically have about 50 to 60% methane. Well, according to the Department of Transportation, that qualifies it as a dangerous good. The US DOT regulations are dictated by the Code of Federal Regulations, CFR, and according to 49 CFR 173.115, a flammable gas is any material which is gas at 20 degrees C and which is ignitable when in a mixture of 13% or less by volume with air. So that seems to us to be the very salient point when you're trying to figure out how can I ship my gas. It seems that you then need to determine whether or not 13% of your mixture mixed with air would be within the flammable range for those constituents. So let's look at an example. If you were to collect your gas with a Tedlar bag and the sample was about 55% methane, going back to that DOT regulation in the CFR, 13% of this gas at 55% would be 7.15% methane, 0.13 times 0.55. The flammable limit for methane is 5 to 15%. So 13% of your 55% methane does put it in the flammable range according to that DOT regulation, and it needs to comply with dangerous good shipping requirements. So your option for that methane, for that gas sample, is that you can ship it via ground, or you could use an exemption shipper and you could ship it via cargo. An exemption shipper could look something like this. This is an example of a kit that we buy from a vendor. You can buy it as well. You would take the Tedlar bag and you would put it in this can, looks like a paint can, and you bash the top down. You put the can in a box and the box in another box, and you have this packing material. And then this box is it's a 4G box, and it has labels on it. And this box can go on an airplane, on a cargo. And according to the DOT regs, you can ship up to 1 liter of flammable, non-pressurized gas in this exemption shipper. And you could put 2 half-filled Tedlar bags in this. This would be relevant when our customers are going to take a sample of, say, landfill gas or digester gas, and it has methane, and it also has, maybe they want to characterize it for sulfur. Sulfur compounds only have a 24-hour holding time in a Tedlar bag. So that's pretty short. But I can also say that we receive hundreds of bags on a weekly basis that we successfully analyze within the holding time for sulfur. So you can do it. If you're going to take this approach, you would need to make sure that you fill out any dangerous goods documentation prior to taking it to your carrier, FedEx, UPS, whatever you use. You would also want to make sure that that location accepts dangerous goods. We've had instances where customers have gone out to their landfill, they're all ready to go, they collect their sample, they do the paperwork, they take it to FedEx, and that location does not accept dangerous goods. And so the entire day, the sampling has been for nothing because they can't ship the sample. So if you're going to use this, and the upside to a Tedlar bag is that it's easy. So if you use a Tedlar bag, it's easy, it's very cost effective, but the trade-off is if you're going to do it that way, you need to think about the exemption shipper. FedEx and UPS have software online where you can fill out all the paperwork, so you can do that, but you got to make sure that everything is squared away before you have your sampling event to make sure that it's going to go smoothly on the day that you actually do the sampling. So that's one way that you could do it. Let's say you took your sample with a canister. If you used a 6-liter canister, then again, going back to the requirement, if your sample has, say, 55% methane, if 13% of this gas containing 55% methane were mixed with the air, then your methane concentration would be in the flammable range. And since you sampled with a 6-liter canister, your only option is to ship by ground, because that exceeds the limit that you're allowed to ship by air. The good news is if you had to do that, it would be fine. Methane has a holding time of 30 days in a canister. So if you did have to ship it by ground, it would be slow and it would be not that expensive, and you could do that. So that's one of the options. If you have the luxury of time and you're not in a hurry to get that result, you can ship it by ground. Another option, and this is something that we do pretty frequently for many of our customers. You can take this 6-liter canister and clean it, evacuate it, and then partially fill it with some helium, an inert gas. This helium will then dilute the methane out of the flammable range, and you can ship it normally without any dangerous goods. So this walks through the calculations. If we evacuate our canister to around minus 29 inches of mercury, which is very common for SUMA canisters, we would then fill it back up with a quantity of helium, which we document at the laboratory with a digital gauge. So we have this information recorded ourselves. Minus 29 inches of mercury where we start. We filled up with a quantity of helium, in this example, minus 17.1. Then we calculate how much contains helium and how much is available for your sample gas. So in this example, there's 41% of the canister volume or space is available. So if you then use this canister and you fill it to ambient pressure, or whatever pressure you fill it to, let's say you leave a little vacuum, which we would then calculate at the laboratory, it drops the methane concentration in your canister. And then 13% of that gas now is below the flammable range of methane, and it can be shipped normally without any dangerous goods requirements. Now, ultimately, it is the shipper's responsibility to properly characterize and ship their items. So this is our understanding of compliance with the DOT regulations, but you'll want to confirm this approach and calculations with your trained DOT shipping colleagues. Further, the DOT does specify that specific training is required in order to be able to ship dangerous goods. So those are things you'll want to discuss with your colleagues or with your training department to make sure that you're doing it properly. That is it. It's a snappy 30-minute webinar. If there are any questions at this time, we'd be happy to entertain them.
Yeah, I tell you what, Nicole, while people are gathering their thoughts for their questions, first I want to thank you for your time today, Nicole. And I want to let everybody know that everyone attending the webinar today will receive just kind of a follow-up email from us. And we're going to include in that email a link to our LinkedIn page, so you can follow us on LinkedIn and make sure you see, because we'll post all of our future Webinar Wednesday topics and links to register for those on that LinkedIn page. So keep an eye out for that email as well. And I want to thank everybody for attending as well. If there are any questions, like I said, just feel free to enter them in the chat box or raise your hand, and we'll go through questions now.
Or follow up with us via email or with a phone call.
Yeah, and Nicole's email is just her first name, Nicole, last name, Bryson, @alsglobal.com.
All right, well, I think that we can wrap it up. you have any questions, please don't hesitate to give us a call or email, and thank you all for your time.
Cole, I do see one question coming in.
Okay.
It's from Tony. It
Mm-hmm.
says, discuss using critical orifice assemblies and metal when landfill gas sampling.
That is a great question. Thank you for that. This would be with regard to, I think, sulfur testing in particular. For all of those parameters that we talked about earlier, typical landfill gas constituents, methane, VOCs, fixed gases, TGNMO, all of those parameters can be sampled with standard equipment that you're used to, a SUMA canister, flow controller, critical orifice, grab sample. Those are all pretty straightforward. What you have to think about, though, is if you're trying to characterize sulfur compounds, and that can be hydrogen sulfide, any of the reduced sulfurs, mercaptans, are unstable when in contact with stainless steel. So that means you do not want to use a traditional stainless steel SUMA canister if you're trying to collect sulfur compounds. The hydrogen sulfur bond is very unstable and it degrades when in contact with stainless steel. For that set of chemicals and compounds, for reduced sulfur compounds, you want to collect them with either a Tedlar bag or something else that is inert to sulfur compounds, such as canisters. They're lined with a glass-like substance, which in our industry is typically referred to as Silco canisters, silanite, glass-lined. So you can use any kind of glass-lined canister to collect your sulfur compounds. That means, and I think this is where the question is, a really good one, that includes right down to your critical orifice or flow controller. There has been consideration given to whether or not the flow controller and the critical orifice need to have silanite coating. If you are looking at very low reporting limits or really low levels of sulfur compounds, you do want to make sure that your critical orifice and your flow controller are also inert to sulfur compounds. So that would mean communicating with your laboratory that is, that's one of the parameters you're going to sample, and they need to provide you with flow controllers or critical orifices that are special or can accommodate sulfur compounds that will also protect them from that degradation. So that was a good question. Sulfur compounds in a Tedlar bag have a holding time of 24 hours. It's tight, but you can do it. Sample later in the day if you can. Ship for your laboratory for first morning delivery, and we can meet that holding time. If you collect your sample in a glass-lined canister, a silanite Silco canister, according to the method, the holding time is then increased to 7 days. So the upside to sampling with a glass-lined vessel is that your holding time is greatly extended. It's a little bit more expensive for the sampling media, but it makes the sampling a little bit less hectic for many of our clients who don't have to worry quite so much about the holding time. Thank you for that good question.
Thanks, Nicole. I don't see any other questions at this time, but I want to thank you again. This was extremely informative, and I think you all agree that Nicole knows her stuff with this, and she'll insist that she's not the expert. The real experts are some of the project managers and chemists that you would work with at that Simi Valley laboratory. They just have a wealth of experience and expertise there. And in addition to that, they're exceptional at client service and responsiveness as well. They do an extremely good job there at the Simi Valley laboratory. So thank you, Nicole. Thanks again to everybody for joining. Keep an eye out for future webinar Wednesday topics. We appreciate it and enjoy the rest of your week.
Thanks, Jared. Have a great day, everyone.